Okay, so we're talking about inverse functions. We talked about inverse functions last week. Everything, the key word here is everything is in reverse. It's either in reverse or it's opposite. Everything. Okay, we're going to look at it not just the function itself, because last week all we did was look at this function. We didn't look at a table. We didn't look at a graph. We just reverse engineered the function by working backwards, right? Now we're going to do that using the table and looking at a graph. We're just going to do it multiple ways instead of one. All right, so first thing we're going to do is let's build up a table for this function. All right, so let me zoom in on just this one here. Okay. Oh, let's start. Okay, so for this one, I'm going to start off with 0, 1, and 2. Okay. So if I plug in 0 to this function, it's just 3 times 0 minus 6. 3 times 0, 0 minus 6, negative 6. Then I'm going to plug in the 1. 3 times 1, 3. Minus 6, minus 3. All right, then I plug in the 2. 3 times 2, 6, minus 6, 0. All right, now you really honestly don't need to plug that in because most of you guys should know how to graph that, right? Start at negative 6, go up 3 over 1. But we're looking at that because we want to see what the table of the other type of function looks like. Right, Bewar? All right. Okay, so let's go ahead and graph that thing. So we're going to start with 0 minus 6. So 0 minus 6 down here at the y-intercept. So 1, 2, 3, 4, 5, 6. Then 1 minus 3. 2, 0. Okay, I'm going to go ahead and make a nice straight line there. All right, and that's our first function. So every time I write the first function, I'm going to highlight it in pink. Highlight the function, the table, and the line itself. Okay. All right, now let's take a look at the inverse function. Now, in order to do that, we got to create it, just like we did last week. Okay, so let's set up a little chart here like we did last time. And first, we got to figure out what are the operations that for the first function. Think of PEMDAS. What goes first? There are no parentheses here, so what's first? Multiply what? Multiply 3 is the first operation. What's the next one? Minus 6, right? So now, to create the inverse, what do you start with? 3 or 6? The 6, right? And then you do the opposite. So what that ends up being is x plus 6 is your first step. Then what's next? Divide 3. All right, so now I'm going to write that out. So f of, and what do you write differently on the f of x? Negative 1 equals x plus 6. And then how do I write divide with this one? Put it under. Yeah, put it over. Okay, make it into a rational like that. All right, so now let's create a table. It's okay, I'm kind of getting into the graph space, but that's okay. We'll have room. Okay, because it won't be affected by where it's at. All right, and what I'm going to do is I need to plug in points into that function. However, if I just plug in anything, I might get a fraction, and I don't want to graph fractions, right? So if I plugged in, let's say 1, right? 1 plus 6 is 7. 7 divided by 3, I can't divide that. Now I got a fraction. So what do I want to make sure the number on the top ends up being? What type of number? A multiple of 3. Okay, so let's start off with just 0, because 6 is a multiple of 3, right? So 0 plus 6. So we'll plug in 0. So 0 plus 6, and I'm going to do this all in my head. You can kind of write it out if you needed to. 0 plus 6 is 6. 6 divided by 3 is 2. All right. Then I'm going to go to negative 3. Negative 3, if I plug in negative 3, plus 6, 3, then divide by 3 is 1. All right, now the next one I'll do is negative 6. Negative 6 plus 6, 0, and then 0 over anything is always 0. All right. What do you guys notice about the two tables? What switched? Like, be more specific. Like, what actually changed? So, like here, the x values became the what over here? The y values. And then the y values became the x values. So it's like the inputs and the outputs just switched. All right, so let's go ahead and graph that. So now 0, 2, right here, minus 3, positive 1, and then negative 6 and 0. Okay, so now I'm going to go ahead and create that line. Oops. What line? Oh, from the points that we just made. I just graphed them. That's 0, 2, that's negative 3, 1, and that's negative 6, 0. All right, so I'm going to highlight the inverse in blue. And as we graph these, you're going to notice a pattern about the graphs, about how they relate to each other. Okay, but the first thing we figured out is that inputs and outputs switch. Okay, it's not the most math technical term, but just kind of getting a general idea of what's going on with these inverses. Okay, the inputs and the outputs are switching. Okay, when you do the inverse. Okay, so the next one. All right, so what I'm going to start off with this guy is we're going to go negative 2, negative 1, 0, 1, and 2. So we're going to do 5 different points this time. All right, so now starting with negative 2, negative 2, if I plug it in here, I get it'd be negative 2 cubed minus 5. Now, negative 2 cubed, meaning you multiply it 3 times. Multiply negative 2 3 times. Negative 2 times negative 2 times negative 2. What do you get? Negative 8. Okay, then negative 8 minus 5, negative 13. All right, so then same thing here. Negative 1 cubed. If I multiply negative 1 3 times, what do I get? What kind of, is it negative or positive 1? Oh, it's going to be negative. So remember, if I multiply negative 1 times negative 1, negative is positive. But if I multiply another negative, now it's negative. Okay? So basically, every time it's an even power, right? It's always going to be what? It'll be positive if it's even. Oh, my fault. Okay, so then minus 5 would be minus 6. Please be using a pencil today, by the way. People were complaining in the last class. Like, oh, you keep erasing. I was like, well, welcome to live notes. Okay. All right, so then the next one, 0. Okay, 0 is 0, right? That's just minus 5. All right, positive 1 cubed is just 1. 1 minus 5 is negative 4. And then we already know what 2 cubed is. It's 8, except this time it's positive 8. So now it's minus 5, which is 3. All right, so starting with the first point, negative 2, negative 13. That's not going to fit. So skipping that one. All right, -1, -6. -1, -6. That's right here. Let's move this over a little bit. Okay. All right, then the next one, 0 minus 5, 1 minus 4, and 2, 3. And just to get a better idea of what this actually looks like, because right here, it's not a straight line. It doesn't go straight up. There's like a little curve in there. So if you guys remember, these graphs, it kind of like goes up, it like bends a little bit, flattens out, and then goes back up. So we want to show that in that, oops, sorry. We want to show that right there at that point. So this kind of comes up from the bottom. Oops, my fault. Hold on, wait. Okay. Comes up like this, starts to flatten out right there, and then bends back up through the other point right there. And goes straight up. Like that. Okay, so now let's look at the inverse. All right, so first let's create the inverse. So again, think about PEMDAS. What's the first operation? Okay, yeah, but when I ask that question, I'm just talking about that function. What's the first operation for that function? Okay, exponents, which is cubed. Okay, then what's next? Minus 5. All right, now when we make the inverse, what do we start with? No, remember we go backwards. So remember, if that's the last one, that becomes the first one. So when I write the function, it'll be x plus 5. And then what? Cube root, right? So remember, the opposite of cube is to root that same thing. So the way, again, I'm going to write this out how you say that. So it's cube, like this, root. If it's a 2, what do you call it? Square root. If it's a 3 cubed, what if it's 4? Just fourth, like with the th on the end, fourth root. And after that, it's just fourth root, sixth root, seventh root, and so on. Okay. The only special names are the 2 and the 3. All right, so now let's do the inverse, which is going to be, this is going to be G, not F. Move this down a little bit so we can see it all. So we're G of -1 of x. And we're starting with x plus 5. And where do I put that cube root? Do I put over the x, the 5, or where? The whole thing. Yep. I cover the whole function with the cube root. Now, the last time the last graph, I calculated each of these points. But knowing what we know about the table from the last one, how could I quickly figure it out?
Copy paste.
Okay, so copy what and where? Switch what? Be more specific. Okay, so what do I write here first on the inputs?
3 and 2.
Okay, so no, not 3 and 2. What do you think, Fawaz? Yeah, -13. What's the next input? -6. So -13 goes with what? -2. And then -6 goes with -1. So all you're doing is switching the inputs with the outputs. I'm just flipping them. All right, so now I'm going to go -5, -4, and 3. And then just make sure I have the matching values to go with each number. Okay, so take this moment. I'm going to highlight everything just so we can keep it all separated here. All right, that's the first function, or the original. All right, then we have over here g of -1 of x table, and now we're going to graph that. All right, so again, we can't graph this one, so we'll skip to just graph these four. Negative 6 and 1. So negative 6, that's like way over here. And negative 1 right there. Negative 5 and 0, so right there on the x-axis. Negative 4 and 1, right there. And then 3 and 2, like that. So just remember, you're creating the same shape. You're just going to do it over here. So here's what I'm actually going to do to kind of help myself visualize this. So I'll actually flip this whole thing. You don't have to do it this way, but it's sometimes kind of helpful to help you see it. So now I'm going to do that same pattern like I did before. I'm going to come up through here and kind of curve and flatten out. Then come up through there again. And now I'm going to work my way up to this point. Just like that. This one I could probably make a little less of a curve right there. It's a little bit too much of like a 90-degree angle. So something like that. Again, these don't have to be perfect. That's just me being a little picky about how I want it. And then if you look at it, it's like the same thing kind of flipped around. All right, so now that one looks like this. Okay. Now, what you're going to notice is that all of these reflections always flip over the same point or the same line. And that line is right down the middle. So if I was to put a line right down the middle of this graph and right down the middle of this graph, where do you think that line would go?
2, 2.
2, 2? Okay, so that's 1 point. Where's another point on that line?
0.
0, where? What do you mean 0? 0 what? The origin right there. Okay, so 0, 2 here? Here? No. So think about a line that goes straight through here. What's the slope of this line?
Infinite.
No, the slope.
It's 1.
Well, there's the next point, right? There's the next point. What is slope is this? Is it 1 over 2, 2 over 2? Like, what is it? 1 over 1. Okay. Now, what I'm going to do is create like a dashed line here. And what we call this is the line of reflection. Okay. What is the equation for that? Y equals x. Good. Slope is 1 and the y-intercept is 0. Okay, same thing here. Start in the middle, go up 1 over 1. And just make a dashed line going straight through the middle. Okay, and I'm just going to label it as y equals x. So again, that's the line of reflection. So somewhere here I'm going to write inverse line of reflection. And every single one of these is going to have that same line, no matter what. No matter what it looks like, they'll all flip over this same exact line.
Is it always over the origin?
Well, this always passes through the origin. So this line is literally going to be the exact same for every single inverse.
I did it on the wrong graph.
What you did on this one, to the right? Well, guess what? You're still going to need it. So if you did, it's fine. Okay. All right. So now with this one, okay, last example here. All right. So we're starting off with this function here. What kind of function is this again?
Parabola.
Parabola. And what do all parabolas start with? Where do you start every parabola? In the vertex. What is the vertex?
Plus 1, plus 2.
So that's where I'm going to start my table. I'm right in the middle of the table. I'm going to put that 1, 2. Because I know that on each side of the vertex, how do we describe each side of the vertex? They're what to each other? they're symmetrical, right? So if I have one side, it's easy to find the other. All right, so I'm going to go to the right of this point. What's the next number to the right of 1?
0.
Or what number comes after 1? 2. And then 3. And then I'll pick 2 numbers going the other way. What would be going to the left?
0.
0, then what? -1. All right, so now let's start the first one. So whatever 2 ends up being, which of these will be the same? The 0. Okay, and whatever 3 ends up being, what will be the same? The -1. Okay, because we know it reflects. All right, so if I plug in 2 minus 1 squared plus 1, well, 2 minus 1 is 1. Squared is just 1 again, plus 2 is 3. So that means that this is also 3. Okay, so that goes there. And then if I do this one, 3 minus 1 squared is 2. 2 squared, 4 plus 2, 6. And again, that one goes there. Because again, that they're symmetrical. All right, so let's go and graph that. Start with the vertex. So that goes here. 1, 2. Then let's go 2, 3. 3, 6 right there. And I could do a quick little line of reflection, or just kind of jump this over to here. There's that point 0, 3. This one I flip it over to here at 1 minus, or at -1, 6. Okay, so now I make my U. Okay. Now this time, instead of making the table or recreating the function again like we did last time, we're going to just use the idea of that line that we're just talking about, the line of reflection. Okay, so make your line of reflection going right down the middle of the graph at a diagonal, 1 over 1. All right, so remember, everything is reflected over this graph. Gorgis, take those out. Everything is reflected over this line. So if I'm reflecting the vertex over this line, what is the coordinate of that new point?
0,
Oh,
2, 1.
2, 1. Because here it's at 1,
Oh,
2, so it goes with 2, 1. Paulo, what's another point? Where's this point go? 3, 2. Right there. And if you look, you can see it goes straight across. As a matter of fact, if I put this line straight up and down like that, it makes it a little easier for you to kind of see that, because it goes straight across. All right, so if I take this one, where will this one go? Goes over straight over there to 3, 0. Okay, if I take that guy, where does this go to? This is at 3, 6. Where does it go?
6, 3.
Right there to 6, 3, straight across. Okay, and then the last point, this guy way over here, -1 and 6 will go to what?
6.
6 and -1. Okay, so you can either do what I did, kind of turn your graph around like this, or just look at the numbers. Remember that we flipped the numbers around, right? 1, 2 becomes 2, 1. 3, 2, or 2, 3 becomes 3, 2. They all flip around. So now I make a U that's kind of facing out. So there's the inverse. So here's the original function, f of x. And then this one is f -1 of x here. Oops, I didn't mean to label that blue. Sorry, that's pink. All right, just like that. Okay, a couple questions here. Question A. Is f of x a function? Is it a function? Yes or no?
Yeah.
Yeah.
How do you know?
That's the line.
The line test, the vertical line test. So remember, you take a line, right? A straight line, and pass it over your function. When is it disqualified or when is it not a function? Twice, right? Okay, so this is a yes. All right, and then obviously the same question for the next one. Is that a function? Is the inverse a function?
No.
All right, well, let's check it out. So is f of -1 of x a function? You guys probably already know the answer to that, but I'm just kind of putting in your notes.
Is that a vertical line or horizontal?
Vertical, good question. It's not this guy, right? That's horizontal. It's got to be vertical. Boom. Right there, you can see that it's touching both at the top and the bottom of that parabola once it's facing out. So that's not a function. All right, check out your packets. Yes, the new one. Go to the second page. Yep.
I didn't get one of those packets.
Right here in the box. On the top, yep. Anybody else not get one of these last week? Yeah, on your way over there, can you give this to Lizelle? You're okay with using your bathroom pass? For what? You're okay with using your bathroom pass?
Oh, yeah. Oh, no.
Sure. All right. Everybody always changes their mind when I remind them.
For the bathroom passes, they don't have to credit if they don't use them.
Yeah, so basically ends up being extra credit. Okay, so this one, they give you a function, they give you an equation, they want you to create the table and the graph for it. So here's what I suggest, because they want you to create the table first. And if it was like a whole number, that'd be easy, right? And just pick some numbers and plug them in. But fractions require a little bit more work, so here's what I suggest. Graph it first. So graph it first. Because if I graph it, it's easier to find the points to plug in or to put in the table. So start at -3, up 1/2, and I'm going to go back the other way, down 1, left 2. So again, all I did was graph the equation. Now there's my points that I can plug in the table. So I'm just going to pick any 5 of these, because if you look over here, I need 5 to fill in the table. So here I go, I'll start with the first one, -6, -6. Then -4, -5. Then -2, -4. What is that? 0, -3. And then 2, -2. And that sounds about right if you think about it. Like the top number said go up by 1, right? So if you look at the right, +1, +1, +1. Or if you look at the left, +2, +2, +2. So that should fit. Now it should be easy to create the inverse table, because what do you do when you go from here to here? Yeah, just switch the points. Switch x and y. Okay, so you guys can do that. All right, and then you can kind of answer these questions about like what's the relationship between the table and the original function and its inverse. And that's just what we've been kind of discussing, or what I've been talking about up here. Okay, then you're going to graph those two functions. So you can finish this by, connecting those dots and then graphing the other one. So get the points here and then graph the other. Okay, then you can use algebra to find the inverse equation. Okay, so let me show you how to do that, because that's a little different than just using like our method of like figuring out what you do first. Okay, for this the one I'm about to show. For what? This? Yes, I want you to complete this. Or is that your question? I don't know what your question is. No, for this, all you're doing is because you don't need to, right? There's no work to be shown. All you're doing is flipping those points over to here. All right, so what I want to do is show you guys how to use algebra to find the inverse. Okay. Now remember, everything is backwards, right? The inputs and the outputs are reversed. So what you do is you actually take your equation and you flip the x and the y. So instead of putting y first, you put x. And then you put y there. And then what you do is you basically solve for y. So first, if I'm solving for y, what would be the first step? No. I want to get y by itself. Add 3. So now it's x plus 3 equals 1/2 over times y. So the last thing is to get rid of the 1/2. How could I do that? No, not multiply 1/2. Oh, wait, what did you say? I could divide, but that gets kind of messy with fractions, right? So instead, yeah, just multiply 2. Because think about get rid of a fraction, right? Fraction busters, just multiply the denominator. So this times 2 and all this times 2. This cancels out. And then we get y equals, I'm going to put the y on the other side. Let's flip it over. It's 2 times x plus 3. Or y equals 2 what? 2x plus 6. Okay, so that's how you use algebra. So instead of so you could do that with every problem. Of course, some are more complex, right? If I have to deal with like a cube or something like that, it gets a little more complex, but you could do that on all of them, okay? All right, I want you guys to work on finishing the rest of this page.
This page or no?